Hi, in this video we will learn some formulas that can be used to find the value of the summation. As you will notice very soon that finding such formula is not easy, and we will have only very specific forms of summations that we can evaluate their final value. Let us start with an easy formula that when you have sums of 1, I going from 1 to n. What does this mean? This means that while you add 1 to 1 to 1, how many times it says go from 1 to n? So it means that n times you have this, and obviously that is n. And as a result of that, you see that if you have any constant, sum of constant I going from 1 to n, this is going to be c times n. That's the formula. Let me write it as formula 1. Formula 2 is another interesting formula, which is, okay, how about sum of I going from 1 to n? Means what? Means that you add 1 to 2 to 3 up to n. The trick which gives us the formula is a very nice trick. It says that you write it this way. This is the value we want to find. Also, this will work the same way if I start from n, then n minus 1, then n minus 2 up to 1. So you add now the first column. You get n plus 1. The second column, this is another n minus 1 plus 2. This is n plus 1. This will give us another n plus 1. And the last one, all of them will be n plus 1. Now, you added 2 of these things, so you added 2s. Yes, this is equal to n. How many of these we have? N of them. N times n plus 1. Then as a result, s is going to be n times n plus 1 over 2. So this is the sum of the integers from 1 to n is n times n plus 1 over 2. Other powers also have formulas. So formula 3 is when you have sum of I squared, I going from 1 to n. This is, these formulas you have to know because we will use when we introduce definite integrals. 2n plus 1 over 6. The proofs are not straightforward as the one you see up there, but there are nice and easy formulas. And formula 4 is when you have sums of I to the power 3, I going from 1 to n. And this is interesting. This is the result is just square of this guy. N squared, n plus 1 squared over 4. There are 2 other summations that you have to know how to evaluate. I will write them as formula of 5 and 6. In this one, you have a constant r to the power I, and I goes from 1 to n. R is a constant. So this has, again, an easy proof. I'm not writing here, but the formula is going to be r to the power that the top or the end in r minus r n plus 1 over 1 minus r. So some things that you have to note, I starting from 1 to n, and then here you have r minus r to the power 1 bigger than the end index. How about formula? This is geometric series. People sometimes say geometric series. Formula 5 is geometric series. The formula 6 is what is called a telescoping series. It is when you have a sum of a term minus one the next term of that sequence. I going from any number you like. Let me just write from 1 to n. Well, what does this mean? This means that you have a1 minus a1 plus 1 is 2 added to a2 minus a2 plus 1 is 3 plus a3 minus a4, and this will go up to an minus an plus 1. And as you can see, a2 cancels this one, a3 cancels this one, a4 cancels. All these will cancel out, but the first one and the last one. So the result is going to be a of the first one minus a of the last one. This is called telescoping. So they cancel and just, you see, like telescope. Yeah. So these are the formulas that you have to know, and we have to be able to use it. Let's do some examples here for these ones. Sum of 5 I cube, I going from 1 to n. First of all, you see that this is sum of cubes, yes? Starting from 1, going up to 10. So n here is 10. There's a constant here. While using the property of sigma, I can put that constant outside. And we know that sum of cubes from 1 to n is, so let me write that 5, is n squared, here's 10 squared, n plus 1 squared over 4. Well, in other words, you have this big number, which is 5 over 4 times 100 times 121. Well, you can simplify that, but I will just leave it like that. How about this one? Okay, I have a formula for sigma of I squared, a sigma of I, and sigma of 1. For the sum, I will use the properties of sigma that I can put these guys out. I plus sigma 1. I goes from 1 to n, 1 to n, and 1 to n. The formula for I squares, there's a 2 up front, is n times n. You note it starts from 1, goes to n. So n times n plus 1, 2n plus 1 over 6 minus 3 times sigma of i's is n plus 1 over 2 plus sigmas of 1 is n. You can simplify that, write it out, and then what you will get there, I don't have the numbers here, but you can simplify it basically. Yes, open it up and then write it as just a constant multiple of n cubed plus a constant multiple of n squared and constant multiple of n and a constant. Very nice. Here I have two things. So I go from 3i squared. I going from 4 to n. Then we have sum of 2 to the power I going from 4 to n. You see the formulas we have up there, all of them are sigma notations or sums from starting from 1. Here I have starting from 4. What should I do? Well, turn them to sigmas starting from 1. How? Well, set j to be I minus 4 plus 1, which is minus 3. Then when I is 4, j will be 1. That's what we want. J will be 1. And when I is n, then j will be n minus 3. This is n minus 3. And also, well, wherever you see I, you can write it as j plus 3. So here I will have j plus 3 squared plus j going from 1 to n minus 3, 2 to the power, instead of I, we write j plus 3. So we have now two sums that we can deal with, each one separately. Here, the first one, I don't know what is the sum, but I can write this, let me write down here, as j squared plus 2 times 3, 6j, plus 9, j going from 1 to n minus 3. And then separate these guys. So this will be j going from 1 to n minus 3, j squared, plus 6 times j, j going from 1 to n minus 3, plus j going from 1 to n minus 3, 9. And then, you see, now I have sums of squares of integers going from 1 to n minus 3, not n. It means that in these formulas, wherever you see n, you have to plug in n minus 3. So let's just go down there again. Here, sum of j squares is going to be n times n plus 1 times 2n plus 1 over 6. But instead of all n's, you put n minus 3. n minus 3 times n minus 3 plus 1 times 2n minus 3 plus 1 over 6. Plus 6 times sigma of j's, integers, going from 1 to n is n times n plus 1 over 2, but this time it goes up to n minus 3. So it will be n minus 3 times n minus, oops, I need a bracket, n minus 3 plus 1 over 2. And this guy is 9 times j going from 1 to n minus 3, so it's 9n minus 3. As you see, this is a sum. Well, I won't do simplification of that, but this whole thing, you can put it there instead of that. How about the other one? Okay, so let's see the other one. The other one is a sum of 2 to the power j plus 3. J goes from 1 to n minus 3. The geometric series, remember that. Geometric series goes from 1 to n. Here, this goes from 1 to n minus 1, and there it is not 2 to the power j. It's to the power j plus 3. So the first thing is that just deal with that 3. I can write this as 2 to the power j times 2 to the power 3, which is 8. And I can put it outside. So this will be 2 to the power j, j going from 1 to n minus 3. Now, this is geometric series, r to the power j, j going from 1 to n minus 1. So it will be 2 minus 2 to the power, the end point plus 1, n minus 3 plus 1, over 1 minus 2. This is just what we have in this formula, yes? And that is what we have. Well, you can simplify and add these two, and this will give us what we have there, up there. Very nice. This is telescoping series. So you see a sequence minus the next entry of that sequence. So if you write this thing, it will be sine of 1 minus sine of 2 plus sine of 2 minus sine of 3, and it will go up to sine of n minus sine of n plus 1. And then this cancels that, this cancels that, everything goes away but the first one and the last one. So that's what you get for that one.